we're going to learn a lot today, because when you get into these older bikes now, the parts are available. They're just really expensive, and already I've spent more than the bike is worth in parts. So we'll go from there. Okay, so now we're ready to install the swing arm. I've gone and made sure that our swing arm bearings are cleaned up, put a little bit of anti-seize in the appropriate spots inside the races of those bearings that the pins are going to sit in, just to make sure that those pins don't seize in there. The other thing we did is take some moly grease and put it onto the top of the boot here that goes against the transmission. And what that's for is to just prevent water from getting down into that area. So to put the swing arm on, we just gotta bring it in the same fashion that we took it off, and that's at an angle, and slide it on up and in, and we start to get it to the back. And now all we have to do is start our pins. Since I don't have an extra pair of hands, I'm just going to use my scissor lift to help hold the swing arm up, and we can put those pins in. And we just want to align the pin with the race. Start putting that in. Of course, it would be helpful if I have the right tool. So we're just going to hand tighten these in. Get them started. Move to the other side. There we are. There's our blind one. And you've just got to align those holes with the pin. Come on, you. Otherwise it won't start. There it is. A little twist required. You don't want to use any force on these, otherwise you can wind up stripping the casting or damaging the bearings inside. The bearings inside this swing arm are sealed bearings, so they're a little more robust than the bearings in the final drive. So, but you really got to be careful on the final drive bearings. So now that we've got them started, we just got to, and again, what this is doing is aligning the swing arm from left to right. So now we've got to get our torque wrench out, get our torque settings, and torque these down. Okay, so now we're ready to torque down the swing arm, and this is where the challenge comes in. This side is pretty easy, the blind pin. We're going to torque to 110 Newton meters. And this is the first step in putting the swing arm back on. All right, so that side's set, 110, and we'll put a mark on it to indicate that it's done. The next side is where things get interesting. So with this side, we have the adjustment pin, and we need to make sure that the lock nut is back far enough that it's not hitting the case inside, or the transmission case. You want that lock nut basically turning freely. You want a gap between it and the transmission case. So we just turn that out. The pin on this side only torqued to 10 Newton meters, so significantly less. Make sure that lock nut doesn't come in contact with the case. Okay, now the trick comes in. This part right here. This now needs to be torqued to 105 Newton meters. The issue with that is you can't turn the inside set pin. So, of course, BMW makes a special tool for this, and I don't have it. This is one I did not go out and buy. So this is going to be a little bit of an experiment to see if we can get this tightened up without moving said inner piece. So we're going to tighten that right down. And it's staying pretty good, actually. You know what? I'm pretty happy with that. It's pretty much in line where I originally marked it. So, bah humbug on the BMW special tool. I don't think you necessarily need to do that. But, the next step we're going to do is bring the back of the bike down a little bit. Kind of make sure that everything's lined up, and then we can put the airbox in. So the first step is just to get some slack here. And so we got this down a little bit where we wanted it. And we've got to make sure that these ugly bolts that go from the transmission in through the bottom of the... I really don't see the value in them from an engineering standpoint, but I'm not an engineer, so somebody must have. That's out of the way. Okay, so now we grabbed our airbox and are ready to put that back in. Oh, there we go. Put that in there. Check your fuel lines, make sure that they're not going to get damaged, because that would be inconvenient. Remember the fuel lines that are mounted to the airbox. There we go. And this guy goes around them, I think, or no, that goes... must go underneath them. Okay. So the airbox there, and again, we're not going to use that crimp hose clamp. We're going to use a more conventional one. So I'm just going to set that on there for now, in the direction in which I can get at it to tighten it and loosen it, which I think is that way. Now, one thing about this crankcase vent that is absolutely critical is when you're done everything, when you've got the back of the bike down, when you've got everything reassembled, just make sure that nothing has pinched this hose. This hose has a couple of functions. Basically, it allows the crankcase to vent back into the airbox, so any gases from inside the engine go back into the combustion chamber. So it's there for emissions, but more importantly, it is there to provide vacuum to the engine and help vent the engine. The vacuum from the intake basically helps vent the engine crankcase, and if this crankcase vent tube is damaged, pinched, not working properly, you can do one of two things. You can blow out a engine seal, main seal, front or back, most likely the back one, or you can blow out the sight glass on the side of the engine, or you can do both. So we're going to check our wires and start lowering this down the rest of the way. So what I meant by checking the wires is this area right here. This is the main wiring harness, and we tried to fix it up a little bit to get it, you know, bare wires covered. And so we just got to make sure that that wiring harness sits inside there. And then this one, I believe, stays ahead of there and there. Those two things go together. So we got to stay ahead of there. Kind of split the difference here with this injector wire, but make sure that this wiring harness is tucked up in there. It stays out of the way. So from here, then our positive cable, again, make sure it's in the proper place, which I believe these wires just sit back here if I remember correctly. So there we go. Like that. So now we're ready to lower this some more. We've got to make sure that we clear the frame to the airbox that's holding it up. We also got to make sure that these tabs, which actually are these tabs right here, which are secure, the lid of the airbox, are in the proper position. And I had to lift the frame up, put that one back, and now I've got to do the second one. So there we go. And we're both in position. And then we've just got to slide the airbox forward enough to clear. There we go. So now we've got the airbox clear of the frame, and everything's sitting down much nicer, much neater. I'm just going to route these wires through here. These wires, remember, are for the neutral and gear shift indicator. So those get tucked in here and then get routed up to the harness. And there we go. Okay, with our airbox secure, we've got the 3 bolts in there that hold that in place. We can go ahead and hook all this back up to our intake. With the airbox pipes that come out of there, go into the intake. There's only one way that these come out that can be hooked up, and that's with this line right here. It's kind of faint on this one, but there's a line right there, and it has to kind of go on the outside, so in line with what you see. And just slide that on and get it over the that rubber O-ring and up tight to the intake manifold there. And once you got that in there, you can go ahead and secure the hose clamps down. Okay, so now it's time to put the fuel line back on. So we're going to take this clip back off. Remember, we put it there after we took the fuel lines off. So we're going to go ahead and re-secure that fuel line on there. A little bit of lubrication and get this fuel line sucked down on there. Grab our clip. Clip goes in from the side. So yeah, the clip goes in from the side, and then we turn it 90 degrees like so, and that way it can't come off because we have the fuel injection electrical leads that go up in here. So when hooking up the fuel injection system and running these sets of wires, you're going to notice on the left side of the bike that there are two connectors that are the same. One thing you got to remember is that the green with white stripe and the yellow wire here, that's the fuel injection system. Okay, so that one goes up onto the injectors, and it's the same color as what's on the other side of the bike, so you can always identify that. But so remember, we had these two lines that came out of the transmission, these two sets of wires. They go into the main wiring harness. One is for the neutral switch, one is for the gear shift indicator. We just want to find the connections for those. I've kind of routed them up. I haven't secured them with zap straps yet. I will after I get everything kind of set. This plug here came out of that one there. So I'm going to snap that back in. I'm pretty sure this is the neutral switch. But more importantly is, actually before I do those up, I've got to point out a mistake that I made. And it's a mistake that I'm pointing out, so you don't have to make it too. When we hooked up the fuel injection electrical lines here, there were two sets of plugs, and you see that they're pretty much identical. And I had taken the wiring harness and kind of taped up some of the areas where the loom was in rough shape. And originally this was tucked down and this one was kind of sitting up here, so I just glanced at it and went, oh, okay, so that's for the fuel injector on this side. Big mistake. This long line here is for the airbox, goes on top of the airbox. But unfortunately what I've done is I've routed it underneath the frame here. So now I'm gonna have to take the frame back up, loosen off the airbox, drop it a little bit, and get this running under this frame rail and up here, because it needs to plug into the top of the airbox up here. So a little confused when I first looked at this, and I was like, where does this one go? And then I had to think about it a bit, and the answer came to me. But how you know that this is the injector line is that it has the green and white wire with the yellow wire with, I think that's a gray stripe, silver stripe. So this one matches the one that's on the other side. So we're going to put this one in like so and lock that down. So off camera, I'm just going to unbolt this and get this line running back under where it should have. So with the next step is to secure the frame bolts to the transmission and up here at the engine. Remember, these bolts, they're all the same length. Did put some anti-seize on them, so we're just going to go ahead and secure these guys. Get them started a little bit by hand. And the only one that's a little bit odd is on the right hand side behind the brake lines here. This bolt goes in along the length of the bike into the transmission. So if you wind up with an extra bolt, chances are you left this one out. Now these bolts on the frame here on each side are torqued to 21 Newton meters. Okay, so 2 bolts done. Now do the other side. We're caught back up. We've got everything routed where it should be. We've got the subframe bolts in and torqued to spec. Now we need to torque the pinch nuts, which are right here. And these are torqued to 42 Newton meters. So these are 16 millimeter hex heads. And remember, if you don't have a 16 millimeter socket, that's okay. Chances are you have an Imperial 5/8, which is the same thing. Okay, that one done. Now it's time for the other side. So there we go. Brake lines back on. And I was confused. At first I had to go double check that these brake lines don't go and inside the frame rail. But they do get twisted up a little bit through manipulating them. But yeah, they definitely go on the outside of the frame. And if you had them on the inside of the frame, it'd be really difficult to move around and it'll interfere with the clutch. So, just a routing note. Like I said, they go on the outside. But after bending these lines a little bit, moving things around, that was the issue, was that they didn't quite sit properly. So you just have to bend the lines back in order to get them to sit the way you need them to. So just getting ready to put the final drive in. So we're going to connect the rear shock. When you're working with bolts that go into places like this, you just want to give them a little coat of anti-seize, and that way they'll be able to come out at a future date when you need to have them out. This particular setup with the swing arm, if this bolt was stuck in there, you'd really be hooped to try to pound it out, since you can't get to it from that side. So a little bit of anti-seize and save, if not you, the next person in line, a lot of grief when it comes to taking this off. Wipe off the excess. And then on the far side, I'm just going to use just a dab of some thread lock. Not a lot, just to make sure that we don't have any issues with this coming off down the road. We are good to get the final drive ready and get it mounted up. So we're almost ready to get this back in, final drive, and wanted to talk again about phasing the drive shaft, keeping it in phase. And if you remember, when we had the drive shaft out, we marked it where the yokes from the drive shaft extended. So basically on the opposite end of this drive shaft that's down in the swing arm now, you can kind of see it right there. So we marked the drive shaft to stay in line with the yokes. And down there are some blue markings on the drive shaft. They line up with the yokes on the opposite end. So we need to line those up with the yokes on this end. So that's what the blue marks are about. So we're going to center those up and get this together. The next thing we're going to have to do is just prepare the bearings that are in here. I'll give them a little clean and put some moly grease on them. And then once they're back up in, or as we start to go in, we can then get the races in there, and hopefully they sit nice and tight with the grease packed around them, and we can get the bolts in. Now the other thing that you're going to notice about the drive shaft, is it's kind of sitting down, kind of funny look. Makes it very, very difficult to get this splined into the final drive. So that's an issue. What we're going to do is just lift that up with some a shop rag, and hopefully that'll get it up high enough that we can get the final drive started in there, get the spline started, and then we'll pull that rag out before we finish bolting it in. This is definitely one of the worst parts of doing the drive shafts, looping splines, that sort of thing, and taking the drive shaft out on a BMW. Getting the final drive back in and seated, I think, is one of the difficult things to do, especially if you're by yourself. Again, another one of these things where an extra set of hands can help out quite a bit. You need to align the splines and get the final drive up and into place. So we've got kind of everything set up. I've got the scissor lift here. We'll use it where we need to. But for right now, what I'm going to do is try to get this thing splined together and keep it phased. There it is. Okay, drive shaft is in, and put this pin in to help hold everything in place. Brag is out. Yeah, it's not in properly. The trick here now is to make sure I don't mess up the races that are in those bearings, that they don't fall out or anything stupid like that. So in order to align these up, and then always make sure that these pins go in freely. Shouldn't require any force to get those started, and check them to make sure that they're aligned. Like this one is not in alignment. So the other thing that can happen is that you can get the bearings damaged inside there. The roller bearings, they're really simple setup, so you got to be careful. Make sure the race is set, is turning normally, that you don't have any issues with those bearings, because they actually can come out of the cages. Okay. There, that looks like it's lined. And again, the factory manual says, the older ones say to put thread compound on here, some sort of thread lock. We're not doing that. BMW has since changed that, and you're not supposed to put thread locking compound on there. There it goes. Once these are aligned, things should go a lot smoother. There it goes. Yeah, see how freely that goes in? No problem whatsoever. So as we did with the Swingarm on the final drive, the blind pin on the right side of the bike is 150 Newton meters is what we torqued that to. There we go. And then on the other side, the Allen pin, the adjustment pin, is only to 10 Newton meters, and then we torque the lock nut to 105 Newton meters. And if we do this correctly, those bearings that are in there will last a very long time. The other thing we got to remember with this lock nut is that it has to be backed out far enough that it doesn't interfere with setting the torque. Okay, now we're going to do the same trick that we did on the other side, and that is to mark a spot along as a reference point to make sure our Allen doesn't move when we go ahead and tighten the surrounding nut here to 105 Newton meters. It's in line still. And there we go. And we lucked out really well on that, so no need to buy that BMW special tool. The marks all line up. So when we set this to 10 Newton meters, we were able to torque the lock nut to 105 Newton meters. The final drive is now in and on the engine, and the transmission's in gear, and we got good spline connection, everything's lubed, and we're good to go. Now, we did lose some oil out of the final drive, so we're going to make sure before we start the bike up and things like that, that we have adequate oil in the final drive. The other thing I mentioned is it looks like the input shaft seal on the final drive is leaking a little bit. Not a big deal. Oil is caught into the into the boot here in front of the final drive. You know, it measurably, you're not seeing a lot of oil based on what I had measured in the final drive. Like, the oil isn't coming down, so I'm not overly concerned about it. It is a fairly common issue with this final drive to have some oil seepage on the input shaft. If down the road I decide to fix that seal, you know, this is easy enough to take off. Getting this back together is the hardest part for sure. So I'm back in the garage after a week of regular work to finish up this BMW. The clutch change that we did on it. Today we're going to put the exhaust system back on and also the rear wheel, and then start to put the rest of the bike back together, the fuel tank, panels, and so forth. Now, there's a couple things that I am waiting for. What we found when we started to take a look at the final drive is that the ABS sensor for the rear, one of the spacer washers is bent up, missing, like messed up, and what it allowed the sensor to do is come in contact with the rotor inside the final drive, and it kind of did some wear on my face. So I'm hoping that this is the problem that I have with the ABS system on this bike, where even after reset it works and then doesn't work and is highly intermittent. So I'm hoping that that's all, that somebody just messed up that spacer and caused this issue. So I have a new sensor coming and some additional spacers. The other thing that I have coming is a new set of front rotors. If you remember there in the first video that I did on this bike, I mentioned the fact that the front rotors are a little jangly, which is not cool. Basically, they're loose on the bobbins, so they move around and make a rattling noise, and you can in fact hear that noise when you ride the bike. That's not something that you want. Basically, you can get into a situation where you're really doing some serious braking on the bike and find out that the bobbins just pop out from the rotors when they get loose like that. They're not quite at that stage here, but it's nothing that I like to have, is loose rotors and bobbins. So I have another set of those coming, which we're going to change out.
Rod Rant.
In preparation for doing this video, I did go and reference some other videos. In other words, I went and watched how other people had done their videos, and looked for, you know, camera angles and things like that, and tried to put together the best job that I could. I can't stress enough how much work and effort goes into making a video like this, a technical video, repair video, and do want to support those people that are creating this original content and putting it up on YouTube. One that particularly stands out for me, and one that helped quite a bit, was a video by a fellow by the name of Chris Harris. And I'm sure that you're a BMW R1100, 1200 owner. then you've probably seen some of his videos. And I did come across one of Chris's videos on another YouTube channel, on somebody else's channel. He had basically taken Chris's entire video and then kind of did a pop-up comment as Chris performed his work. That's not original content, and I did call him out on that in his comment section. What concerns me is that you know, nobody really does this for the monies per se. It's all about sharing information. But this particular person was using Chris's content, and I didn't think that was an appropriate way to do that. Again, a lot of work goes into this, and you want to have people come to your channel to view it. So that's why it's so important that you hit that like button. That makes sure that this video gets seen by other people who have similar interests to your own, and why it's so important. So I did want to make note of that. Please support original content providers like myself and like Chris Harris, and the guys who are actually going and putting the time and effort to make these videos. So look forward to the next one coming up on our R1100, and we'll see you soon. And I'm going to put a little bit of anti-seize on the rear bolt. And then line that up. Now, if you remember on this bike, had those two rubber mounts that go on the bottom of the catalytic converter. It's not required for support. I have left those free. We're not going to worry about that. The only thing I am going to worry about is getting this O2 sensor plugged in. So we're just going to route the O2 sensor up to its original position, which is up here, and this threads in. Once it's plugged in, there's a collar that threads. That was it. Tighten that up. Away it goes. Hopefully there you can see the bump, and then that hole goes on there. So we're gonna line those up and then slide this on. Just a little tappa.
Just tap it in. Just tap it in. Give it a little tappy. Tap-a-roo.
And we're home. So then comes our D-wedge. It's in there. And then our washer and nut. So this is a 15 millimeter nut. And again, hopefully in a few weeks we'll have this off. Changing the exhaust system, so I'm just gonna get it tight enough. And then we'll tighten the hanger in the back. And we're good. So the one thing you want to remember when you're installing the rear wheel on this BMW is the spacer. And the spacer goes up against the final drive on the wheel. There's a flange there for it. So if you forget this spacer, it runs the wheel off and you can do some damage. So you want to make sure You never ever lose or forget this spacer when you go to put it the wheel back on. Remember that your wheels are unidirectional. In other words, they only go on one way. We'll grab our wheel nuts, wheel bolts. Remember they have a taper here, spacer that goes on just like that, and then they go into the hub. I do put anti-seize on the threads. I don't believe that certainly hurts anything. I don't believe that these will back out with anti-seize. I've found that anti-seize actually adds just a little more friction, and it's less likely for it to back out. It doesn't make it easier to back out. If you've heard of somebody who used anti-seize and their wheel came off, that's because they didn't torque it. That's straight up. That's the only reason that happens. So a little bit of anti-seize makes these easier to come off, because you don't want these breaking off in the hub. That is a very expensive job, and in a bike like this, you just wind up tossing everything out and having to buy some used parts. And these should just thread on easily. There shouldn't be any need to force them. Start at the top one, the one at 12 o'clock when you're looking at it, and then work your way down and then across. And you should be able to get these all the way up just with your fingers. You shouldn't need any sort of additional tools until you're ready to torque these down. So now that we're ready to torque down the bolts on this rear wheel, remember that it's a two-step process. Initially, we're going to torque these bolts to 50 Newton meters and finish that up in a crisscross pattern. Then come back, and once we apply the brake and things like that, in order to get everything basically situated so that we can get some additional pressure on the wheel so it's not turning over the engine, we're going to torque this down to 105 Newton meters. So just remember that we're going to leave this cover off because we have to circle back here to make sure that we get enough pressure on these bolts to get them to 105 Newton meters. So right now, we're just going to torque them to 50 Newton meters. And just for fun, I'll see if I can get this to 105. Okay, now we've set the torque wrench to 105 Newton meters. Yeah, turning over the engine. So we're gonna have to wait on that. Just gonna go ahead and put the rear caliper back on. And just going to spread the pads here a little bit. I noticed that we do need some new rear pads, so get those ordered up. We can go ahead and put those on after they come in. It's not absolutely mission critical at this point. So by spreading the pads, it makes it a lot easier to get it on top of the rotor. The only thing that I'm going to caution you on is that you're going to have to pump up those pads and get them in contact with the rotor again. So don't trust it if you ever do that first time out. So like I said, we do have some anti-seize on the bolts. Start them by hand. Just remember this forward one has a bracket here for the speed sensor. I don't know if you can make that out, but there is a little bit of a glinting there. You can see there's a wear pattern in the tip of this speed sensor. I don't know if it's completely done or not. So we'll try with the different spacers and then change that out if need to. And then these bolts are torqued to 40 Newton meters. So with these foot peg bolts, they're torqued to 22 Newton meters. And these ones that hold the brake rear cylinder, just going to tighten up a little bit. So for the brake line switch, it goes up and under into the wiring harness way up here. It's a little harder for me to see with to get up around there, but there it is. There's the connector for it, and it only goes in one way. Like so. And we can go ahead and, pretty sure those wires were meant to be routed up on the inside. So we're going to unplug them. This one is for the speed sensor. And route them up under the frame rails. And like so. Tuck that one away. Brake switch. And like so. Tuck that away. So there you go. And then we can just zap strap those on. Probably around about here. And we should be good. Now that we have the rear brake hooked up, pumped up, and some pressure on it, we can go ahead and tighten these wheel bolts. Again, our goal here is to get to 105 Newton meters. And again, you want to use a crisscross pattern. So happy that our rear bolts are up to torque spec. We'll go ahead and put that cover back on, and we'll be good to go. I'm just going to put a little lubrication in the ball socket for the shifter. A little bit of moly grease again. Make sure we have our clip ready to go. Put that somewhere we won't lose it. Put the ball back in. Socket. Get some light on it for you. So we have the pin. Stick it down in the hole in the top of the ball. And I need to get my glasses for this one. And our shifter ball and socket are back together.